we're going to do a couple together. All right. Diagonals of a parallelogram bisect each other. So our first job is to make a parallelogram. Yes.
What does that mean?
That's Adam Frank, everybody. Adam Frank. There we go. Okay, so we have to make a parallelogram. We have to make the variables guarantee that we're looking at a parallelogram. Okay, so I'm going to choose to put my tip of my parallelogram at 0, 0. There are different ways of doing this, but that's the way, you got to pick one, so I'm going to do that. So we're going to make that 0, 0. Let's call it point A. Now, we're going to go over a certain distance, doesn't matter really how many boxes, because it's just arbitrary distance here. And let's make that over A and up how much? 0. Okay, now when we make our parallelogram, we have to tilt it a little bit. I went 2 boxes over, but you could go 1 box over as long as you are tilting over a little bit. So we have to decide now what is, this is C and this is D. We have to decide what those coordinates are going to be. Well, let's decide what the up is going to be. We went over A, okay? Let's make the up C. Let's make it C. So this distance here is C. So the y-coordinate of both of these is going to be C. Now, there's different things we can do here. What would you like to make the x-coordinate of point C? Right here. What should we make this? If this distance is A, and we go a little bit further, what could we call that? Kyla? A plus B, okay? We can make that A plus B. So now this little distance here is B. Well, if that distance is B, then what's this distance? Also B. So the point, the x-coordinate for D is going to be over B up C. Now, there are other ways we could have done this, but you have to pick one that makes sense to you. Okay? All right, so now we are going to prove that the diagonals bisect each other. There's a hint here. Show that the midpoint of the diagonals is the same point. Okay? So you're going to start with diagonals are AC and BD, and we're going to find the midpoints. Again, when you're doing coordinate proof, remember that labeling and keeping things organized is key, because we don't have 2 columns, we're not writing a paragraph, we're not giving statements and reasons, but it's a proof. You have to justify everything and explain everything that you're doing. Oh, I hate when that happens. Okay. All right, so the midpoint of AC, we're going to add the x's, 0 plus A plus B over 2, and add the y's, 0 plus C over 2. Oops. I need to simplify that, and I ran out of room. Okay, so 0 plus A plus B is just A plus B over 2, and C over 2. That's the midpoint. Now we're going to do BD. BD, add the x's, a plus b, over 2, and add the y's, c plus 0, over 2. So they're the same point. So you're going to want to write a conclusion. Since AC and BD have the same midpoint, then diagonals of a parallelogram bisect each other. So this is really good because this stopped working. Pen stopped writing. I don't know why. Oh, let's see. There we go. Bisect each other. This is going to be a really professional video. Okay. All right. That's the basic process. Number 2 is a bear. It's really, really not fun at all. Because if you want a rhombus, that means all the sides have to be the same. So you have to find the distance and then make your coordinates go with that. I'm going to skip this for now because that's a little bit more advanced. Okay, let's go to the next page. Well, we might get to it tomorrow, but no, I'm not going to put a rhombus on the test. You have it on recording. It won't be on the test. Okay, the segments joining the midpoints of the sides of a rectangle form a rhombus. We did the opposite of that. We did this, okay? Yeah. All right, so the segments joining the midpoints of the sides of a rectangle. Okay, so what is it that we have to draw on the coordinate plane? What are we starting with? A rectangle. Right. So again, there's different ways of doing this. I personally tend to like one of my vertices at 0, 0. That's just the way that I usually do it. You don't have to do it that way, but you could bisect, with the y-axis. But I kind of like the 0, 0 as part of my repertoire here. Okay, so I'm going to make a rectangle where the corner is right at 0, 0. And again, I'm going to make this A, B, C, and D. Do I get like what? Nothing. Okay. Okay. I'm going to say that this distance is A and this distance is B. You guys write your coordinates. This distance is A, so it's a length of A. Oh, actually, we have to do midpoints, don't we? Let's make it 2A and 2B because we know we have to do midpoints. Midpoints, if you make it a multiple of 2, it's going to make your midpoint formula easier. Okay, so you should have 2A, 0, 2A, 2B, and 0, 2B. You have that?
Yep.
Everybody got that? Okay, so now you're good to go. Now, if you need to find the midpoints, you're going to do the, okay, mine are kind of not on an exact point, but you're going to connect the midpoints. So first you have to find the midpoint of AB, the midpoint of BC, etc. It's always helpful if you label your points. Let's call this S, T, U, and V. So the midpoint of DC is going to be point t. And we add the x's, divide by 2, and we add the y's, and divide by 2. So t is going to be a, comma, what is this, 4b over 2, so it's just 2b, which makes sense, over a up 2b. Midpoint of CB is going to be point U, and we're going to add the x's and add the y's to b plus 0, and you're going to get 2a, comma b. Point U is 2a, comma b. AB, midpoint of AB is point V. We're going to get 2a over 2, 0, so that's just a 0, point B. And then AD, midpoint is point S. And we add the x's, we get 0 over 2, and we add the y's to b over 2, and we just get 0b is point S. Now we have those, we have to prove that T, or STUV, is a rhombus. How are we going to prove it? How can we prove something is a rhombus? Four sides congruent. Yeah, we could do what formula? Distance formula. We could do diagonals perpendicular, but if we do that, we have to also show that it's a parallelogram. Okay, so if you do distance, you just need distance. You could do that 4 times, and that will get you a rhombus. Okay, I'm going to pause the video for a minute here.